Hello everyone, welcome to today's class. We'll be starting a new chapter, that is vectors. Okay, so in case you have the idea about the basics, it will be easier to understand. Even if you don't, I'll be starting from the basic anyway. Okay, so be patient. First of all, we have to understand what is vector. Okay, so what is a vector? Vector is basically a quantity which has magnitude. I'll explain what is the meaning of this word magnitude and direction. Okay, suppose you measure something, whatever that measurement is, that effectively is their magnitude. Okay, suppose you draw a line segment. Okay, let's say this line segment. Okay, let's say it's 5 centimeter. So that 5 centimeter is the magnitude of this length. Okay, all right. Now in order to represent the vector, it is represented with the help of an arrow. Okay, so it has a starting point. Okay, it has a terminal point, and this length represents its magnitude. Okay, so that length of vector is equal to the magnitude. Okay, so if we want to represent any vector, basically we show it with the help of an arrow, and the length of it will represent its magnitude. If the length is more or the magnitude is more, so the length will be more. If the magnitude is less, the length of the vector will be less. Okay, that's about representation. Okay, now suppose we say AB vector. So you have 2 points A, B. So if we talk about AB vector, we join them, and AB will, what does AB will represent? It will represent direction from A to B. Okay, then similarly BA vector will be regarding the same 2 points A and B. Okay, but the direction sense will be opposite. It will be from B to A. Okay, so AB vector, if I say, it is from point A to point B. BA vector is from B to A. Okay, all right, that is, now there are the basic. Okay, that's the basic. Now if we try to understand the quantities, the physical quantities, few of them are vectors, few of them are scalars. So whichever quantity has a direction associated with it will be a vector quantity. Okay, although in maths they'll not be asking you that, but still you should have the idea. Okay, all right, now let's talk about some basic types of vector. Okay, I've shown you the representation, how it is shown. The length represents the magnitude. Okay, okay. Next, let's talk about types of vector. So there are certain types of vector that we have to understand. Okay, I told you there are 2 points on a vector. One is the starting point, that's initial point, and one is terminal point. Okay, so this is initial point, and this is the terminal point. Okay, so what is a zero vector? Basically, zero vector means you'll not have a length of vector. I'll say basically your initial and terminal points will coincide. Means this is initial point, let's say, and this is the terminal point. If these 2 points are same point, basically a single dot effectively, so that will be your zero vector. okay, or null vector. Now why do we need that? Okay, what was the whole point of it? Okay, if dot is there, what is the purpose of a zero vector? The point is, like, when you do subtraction, like a vector minus a vector, you cannot write this as 0. This is vector. If you add two vectors, you'll get a vector. If you subtract vectors, you should get a vector. So that's why we define a 0 vector. Okay, so in order to make this validate, it's just that there is a 0 vector, otherwise we'll not be using it anywhere else. Okay, so that's the whole point of 0 vector. So basically a dot. Okay, and if we talk about direction, again, a dot cannot have a sense of direction, so it can have any direction. Okay, so that's the point here. So zero vector can be regarded as having any direction. We cannot be sure about it, no? Now comes the relevant part, unit vector. Okay, so what is a unit vector? So let's say a was our vector. Okay, every time we write something is a vector. Okay, so either we write like this, a b vector, b a vector, or we can represent this with a single alphabet also, a vector. A is some vector. Okay, like that. So unit vector is that kind of vector in which your magnitude is unity, means 1, means the length of the vector should be 1. That's the whole point. Okay, so let's say you have another a vector whose length is 1 unit. Okay, if the length is 1 unit, we'll call this as a unit vector, and it will be represented by a cap. Okay, this is a cap symbol. Okay, okay, so whenever you see this cap, it means the magnitude is 1 for that vector. Okay, so representation is also very important here. Next, co-initial vectors. Co-initial means two or more vectors having same initial points. So how will that situation will be? It will be something like this. Let's say you have one vector here and you have another vector here. Okay, let's say this is a vector. Okay, let's say this is some b vector. Both of the vectors have same initial point, so they will be called co-initial vectors. Okay, so the word initial is pretty much explaining it, what kind of vector it is. Okay, next is collinear vector. Now collinear vector, you have to understand, two or more vectors are said to be collinear if they are parallel to a same line. Okay, irrespective of their magnitude and direction. But I'll tell you, basically I try to understand this as parallel or anti-parallel. Now what is the meaning of anti-parallel? Okay, so let me show you. This is a vector, this is a vector. Okay, this is, let's understand the first situation. A vector, b vector, both have the same direction, both are going towards the right, so both have same direction. Magnitudes are different because the length are different, so I can say a and b are collinear. Okay, so they should have same direction, but this is also the case in which they have opposite direction. So this is the case of parallel that I was talking about, and this is the case of anti-parallel. The lines are parallel but the directions are opposite. Okay, so anti-parallel. A vector and b vector, no, let's name them something else. C vector and D vector. Okay, the directions are opposite, still they are collinear. Okay, next we'll talk about equal vectors. Now two vectors are said to be equal because a vector has two things, a magnitude as well as direction. So two vectors will be said to be equal if they have same magnitude and direction. That's it. Okay, the magnitude should be same, direction should be same. And how it is represented, it will be represented like a vector is equal to b vector. Okay, whenever you want to signify a quantity as a vector, you put an arrow on it. Okay, like I've written here, a, and this arrow, the arrow represents that this is a vector quantity. Okay, okay, so equal vector will look like this. Oh, I have the copy paste, and I'll use that. V. This is a vector, this is b vector. Clearly you can see they have the same direction and almost same length. Okay, actually they should be equal exactly, but okay, I'll try to make them exactly equal. Okay, so now they have the same length and same direction, so I'll say in this case a vector and b vector are equal. Now this time a vector, b vector, the length may be equal, okay, but directions are opposite. Okay, I'll have to slightly reduce this. Okay, the directions are opposite, but this time a vector is not equal to b vector. Okay, length effectively or the magnitude only is not the criteria for vectors to be equal. Okay, next is negative of a vector. Now negative means same magnitude, it's just that you change the direction. Okay, negative of a vector is opposite in the direction. Magnitude should be same, direction should be opposite. So actually this is the case for negative of a vector. Clearly you can see magnitude of a and b. I'll say magnitude of a. Right now I'll write like this: magnitude of a is equal to magnitude of b, but direction of a is opposite to b. The direction of a vector is opposite to that of b vector. Okay, so what we can say that the b vector is nothing but negative of a vector. That is the meaning of negative of a vector. Okay, so this b vector what I have shown is actually minus a vector. So whenever you have to draw a negative of a vector, just reverse the direction, that's it. Okay, same length, reverse the direction. All right, that pretty much sums the basic idea. Okay, now let's see some basics more. Let's understand the concept that we have just understood with help of this example. Let's get it more clarified. This is a diagram given. I'll zoom in. Okay, and you have to identify co-initial, equal and collinear but not equal vectors. Okay, so you have to find equal vectors, okay, second you have to find collinear, okay, vectors, third you have to find collinear but not equal. They should be collinear but not equal. And lastly you have to find co-initial vectors. very simple question. Equal vectors. So first of all, let me clearly mark the arrows. A vector, this is B vector, this is C vector, this is D vector. Okay. So first is equal vector. So the length should be same. It is pretty much looking like a square. So all the lengths are equal. All we have to look for is same direction. Now if we look for these two vectors, your B vector is downwards, your D vector is also downward. So both of them have same direction and same length. So they are equal. So I can say that B vector is equal to your D vector. Okay. Next we have to talk about collinear vector, means they can be parallel or anti-parallel but not equal, he is saying. So that means they should have same direction or opposite direction. Collinear but not equal. Collinear means parallel or anti-parallel, both. Okay, let's see. So which two vectors are parallel? Clearly, first of all, if we write in terms of parallel lines, I can say your A vector and C vector, they are actually opposite direction, so anti-parallel. Okay, no issues. And your B vector and D vector, they are also parallel. Okay, this is not a notation, remember that. I'm just writing for you to understand this right now. Now we have already decided that B and D have same magnitude and same direction, so they are equal. So they don't satisfy this criteria. They are collinear but not equal. So they don't satisfy this criteria. So let's erase them. So A and C are parallel, but are they equal? No, because the directions are opposite. So we can say that they are parallel but not equal. That means they are collinear but not equal. So this satisfies the criteria. So A vector and C vector. Okay. A vector and C vector. Third, co-initial vectors, means they should have same starting point. You can see only two vectors have same starting point, this and this. They are both starting from this point, that's co-initial point. So A vector and D vector, they are co-initial. Okay. All right. Next, let's see addition, subtraction of vectors. Okay. Next, we'll talk about addition of vectors. All right. So let's say you have two vectors, A vector and B vector. Okay, A is from AB. Well, I'll write AB. Okay, so this is your AB vector. So from A to B. This is your BC vector. So from B to C. Okay. So if we want to add two vectors, they can be done graphically also like this, or they can be done in a notation way. We'll be mostly doing in notation way. Let's understand it for once, because some sort of conceptual question can also be created out of this. Okay, so how do this law applies is, first of all, this law is called triangle law of vector addition. So this is triangle law. So you can see clearly why it is called triangle, because it's looking like a triangle. So if AB and BC are two given vectors, okay, so you arrange them like this, that that the terminal point of AB vector and the initial point of BC vector, they coincide. Okay, so remember that these two are the vectors that are given. We have to arrange it like this so that the terminal point of first vector coincides with the initial point of second vector. In that scenario, if we join this point, initial point of the first vector, terminal point of the second vector, so you get some sort of a triangle, and from A to C, this represents the vector addition of these two vectors. So this AC vector, okay, so your AC vector is, I'll write it here, is AC vector is equal to AB vector plus BC vector. Okay, that's triangle law of vector addition. Okay, remember how you have to arrange the vectors, that's very important. So again I'll repeat, you have to arrange the vectors like this, that the terminal point of first should coincide with the starting of the, or the initial point of the second vector. So this sort of arrangement has to be there, and then you join the initial point and the final terminal point, and that direction gives you the addition of the two vectors. Okay, this is triangle law. Then you have a parallelogram law also. Both give same result. It's just that this represents a triangle, that one represents a parallelogram. So parallelogram law. All right. Now for the parallelogram law, what do we, the arrangement is slightly different, rest everything is same. The arrangement is like you take two vectors, your A vector will be like this, along OA. Okay, A, B, C, D are the points just to represent it. Right now focus on A vector and B vector. So A vector is from O to A. Okay, B vector is from O to B. So you have to arrange in A and B vectors such that they are co-initial vectors. This time they were not co-initial. Here A and B should be arranged like this, that they should be co-initial vectors. Then what you do, you just draw length of A vector here, you draw length of B vector, that is represented here, dotted lines. Okay, and then you will get a sort of a parallelogram, and the diagonal of the parallelogram will represent your A plus B vector. So here I don't have to write anything, pretty much everything is written here. Okay, all right, for the time being forget about this, focus on only this, like A vector has to be like this, B vector has to be like this, then you draw a parallel line here, you get some sort of a parallelogram, and the diagonal will represent its a resultant or A plus B vector. Okay. All right, fine. Now let's talk about the more relevant part here. This is so far done, addition, subtraction, this is just representation. Mathematics work around numbers a lot, so let's talk about components of a vector. Okay, components of a vector. Okay, so components of a vector, how do we write components of a vector? Basically the representation follows the idea of quadrants, pretty much, not exactly quadrant, in 3D it's called octant. Okay, so let's say you have a point, okay, x axis, y axis, and say let's say this is z axis. Okay. So you have, say, a point here, the coordinate is, let's say, x1 y1, sorry, x1 y1 z1. Okay, so the position of this with respect to origin, it will be looking like this. Okay, This is the origin O, this is our point P. Okay, so your OP vector, first of all, this is called a position vector, means whatever position is there of the point in terms of coordinate. Now we'll write in terms of vector. How do we write that? Is just add I cap, j cap, k cap with the coordinates. I'll explain what is I cap. X1 I cap, Y1 j cap, Z1 k cap. Okay, so basically, first of all, there is a cap, so you know this is a unit vector. So what is I cap? I cap basically means unit vector along x-axis, but for our interpretation we'll understand this. It represents that this much length you have to cover along x-axis. Okay, this much you have to cover along x-axis. J represents this much you have to cover along y-axis, and k cap. Okay, if sometimes I have the tendency to skip this cap because I have to write a lot of times ijk, so if I do skip it, just ignore it. Okay, but usually caps are always written because that's a notation. Okay, this is along z-axis. Okay, so every time we write a vector, we'll write in terms of x, I, j, k. Okay, and for analogy purpose, I have shown you how does that represents. Basically, if you want to get to this point, you have to move x1 distance on x-axis, y1 distance on y-axis, z1 distance on z-axis. Okay, so that movement will be represented by this vector x1i, y1j, z1k. Okay, all right, so that's your position vectors. Okay, it's not necessary you have to do always in 3D. You can do it in 2D also, like x1 I cap, y1 j cap. There is no necessary condition that k cap also has to be there. Okay, all right, so now let's write a vector and let's see few points about it. Let's say a vector is a1 I cap, a2 j cap, a3 k cap. Okay, and you have another vector b vector, let's say b1 I cap, a1 b1 a1 b1, a2 b2, a3 b3, they will be some sort of numbers. Okay, 1 2 3 4 5 6, anything, negative, positive, doesn't matter. b2 j cap, b3 k cap. Okay, now I'll teach you basic algebra here, how to add, how to subtract. Basically, if you want to add them, what do? You just add I with I, j with j, k with k. So a1 plus b1 I cap, a2 plus b2 j cap, a3 plus b3 k cap. Okay, just understand the idea, no need to learn this as a formula. Similarly, if you want to subtract two vectors, then subtract also with I, j with j, k with k. Okay, a1 minus b1 I, a2 minus b2 j, a3 minus b3 k. Okay, now if a vector is being multiplied by some constant lambda. Okay, I have shown lambda because we will be dealing with this symbol. Lambda is some number, again, don't get worried about it. So what do? If you have to multiply it with some number, so just multiply each component, means lambda times a1 I cap, lambda times a2 j cap, lambda times a3 k cap. Okay, next let's say two vectors are parallel. Perpendicular condition I'll discuss later. First let's discuss parallel. So two vectors are parallel, so a vector and b vector, if a and b are parallel, okay, in that scenario what happens is here I have the tendency to write it short, learn it like this. A vector should be lambda times b vector, means again you should be able to write a vector as some number and then b vector. If I can write a vector as a lambda times b vector, they are parallel. Or the easier way, sometimes students find that very simple, then a1 by a2 is a1 by v1. Basically your components should be in the same ratio. a1 by v1 should be equal to a2 by b2 should be equal to a3 by b3. If this happens, then the vectors are parallel. Okay, if a and b are parallel, they should be equal. If they are equal, we can say the vectors are parallel. Okay, so remember this condition, this is important. We'll be using this in 3D. In vectors also sometimes it is used, but mostly in 3D, whenever the question will ask you to prove some vectors are parallel, or it will be required for you to understand why the vectors are parallel, you have to see this. Okay. All right. Then let's talk about magnitude of a vector. Magnitude of vector. First of all, it will be represented by mod of a. Again, here mod represents magnitude of the vector. How can we calculate the magnitude? So our vector was a1i, a2j, a3k. So how do we get the magnitude? You just get the magnitude like this. You add each component square, a1 square plus a2 square plus a3 square. Okay, that's next point. Okay. Magnitude of vector, this is how you can calculate. Suppose you want to calculate unit vector. Okay, we have understood that a unit vector is a vector which has 1 as a magnitude. Okay, but how do we calculate that? So what you do, suppose you have a length 5. If you want to make that 1, what will you do? You divide it by 5. 5 divided by 5 is 1. So basically, if you want to make something 1, you have to divide by the magnitude of the same quantity. So if I want to generate a cap, unit vector a, so how can I generate that? It will be a vector divided by magnitude of a. Okay. I'll write it like this only. I'll show you the help of example. Remember, the formulas that I'm highlighting, they are very important here. All right. Unit vector, magnitude of a vector, we know how to calculate. Parallel, they are or not, now we have done that. Perpendicular will come later. Okay. All right, this is done, this is done. Now comes section formula. In the vectors also section formula is applied. Remember, for coordinate also you have a section formula. So in vectors also there is a section formula. So I'll give you the formula first of all. Okay. Heading section formula. Okay, again section formula, usually you divide, the idea was like you had a point in between a line segment and it divides it in some ratio. Okay, same pretty much idea here also. So let's say you have 2 points. This time it's just that the point will be represented by vector, position vector. So let's say this point A has a vector as a position, this point B has a B vector as a position. Okay, so in that scenario, let's say C point is there, which is internally dividing this A and B. Now let's say there is a C point which is dividing it internally in, let's say, some M1 ratio M2. Okay. Or you must have studied with M ratio N. I have the tendency to write M1 M2. It's simple that way. Okay. So this is first of all the case of internal division. In the case of internal division, the formula is pretty much same as the section formula you must have studied, that the C vector is given by, you will multiply these ratios like this. M1 will be multiplied with this, M2 will be multiplied like this. Okay. So C vector will be given by M1 multiplied by B vector plus M2 multiplied by A vector upon, sorry, I have written M1 vector, M1 M2 are numbers. Okay. So M upon M1 plus M2. You may be able to recall this with the x coordinate, M1 x2 plus M2 x1, something like this. Again, try to relate it, it's easier that way. Let's say you have another point, again A vector is the position, let's say you have B vector here, and let's say you have a C vector here. Okay, and it is dividing externally, so this is the case of external division. Okay. Internal division, the point lies inside the line segment. External division is the point lies outside. Okay, so this time this much length, so this length, sorry, let's say this length ratio is M1 and this length ratio is M2. Okay, here this was M1, this was M2, na? This length, they are being divided in some ratio. This time the ratio is again M1, this is M2, they are divided like this. So C vector is M1 B vector minus M2 A vector. So instead of plus you have minus, that's it, upon M1 minus M2. So in the, if you want to change the formula to internal, from the internal division to external division, what you have to do is just change the sign, instead of plus use minus. Okay, and then you have the same idea. If suppose you want to calculate the position vector of a midpoint, let's say A is a point, B is a point, A, B, and you want the midpoint of the position vector of their midpoint. Okay, let's say this is C. Okay, C vector is midpoint. Okay, so not C is the midpoint only. Okay, let's forget about the vector. So C vector will be given by what was the midpoint formula? X1 plus x2 by 2. So it is like this, A plus B vector divided by 2. So basically the idea is that the ratio is internal ratio 1:1. So if you put M1 M2 as 1:1, you'll get this same formula. Okay, okay, done. All right, one thing I forgot to mention, sometimes the question asks for direction of a vector. The unit vector is also called direction of a vector. So if a question asks you to find direction of a vector, basically he is asking for unit vector. Done. Done. Let's solve few questions, then we'll look at the concepts. So let's start with a very simple question. Let's do addition of two vectors. A vector is I cap minus 2j plus k. B vector is let's say minus 2 minus 2i plus 4j plus 5k. Your C vector is, let's add three vectors, I cap minus 6j cap plus 7k cap. Okay. Minus 7k cap. And the question says find magnitude of A vector plus B vector plus C vector. So first of all you have to add them. Let's add them. So I'm directly A vector plus B vector plus C vector. How do we add them? I with I, j with j, k with k. So nothing, that means 1i, nothing means 1i. So 1 plus 1, 2 minus 2, 0. So 0i, 4 plus 4 and minus 8. So minus 4j, okay, cap. And minus 7 plus 5 plus 1, 5 plus 1, 6 minus 1, minus 1k or k. I'll just write k. Okay. So this is a vector. Now in order to get the magnitude of it, means A plus B plus C vector magnitude. How do we get the magnitude? You square each component, I component, j component, k component. Component means the value. So you square it 0 square plus minus 4 square plus minus 1 square. So what do we get? Root 16 plus 1, 17 units. Okay. So root 17 is the answer. Okay. All right. Let's take one question. The question is find a vector in direction of 2i minus 3j plus 6k, okay, which has magnitude 21 units. Okay, so you have to find a vector which is in the same direction as this, just that the magnitude should be 21. So let's find first of all direction of this vector, because the question says find the vector in the direction. So let's find direction of this vector. Let's call this as A vector for simplicity. So A vector is 2i minus 3j plus 6k. So A cap vector is vector divided by its magnitude. Okay, so a vector is 2i minus 3j plus 6k, and magnitude will be calculated by square root of each component, 2 square plus minus 3 square plus 6 square. Okay, so 2i minus 3j plus 6k upon 36 plus 40 plus 9, 49. So square root of 49 comes out to 7. So basically 2 by 7 I cap, I'll write it individually, 2 by 7 I cap minus 3 by 7 j cap plus 6 by 7 k cap. Done. That's your unit vector. Okay, now we got the direction of basically your vector. The problem is this has magnitude. This is a unit vector, so it must have a magnitude 1. You want to convert this into another vector which has magnitude 21. So how do you convert 1 to 21? Just trying to think, how did we converted the magnitude, this magnitude was 7, how we converted this vector's magnitude from 7 to 1? We divided by that. So if you want to generate another magnitude, you multiply it by that number. It's as simple as that. So if we want to generate a B vector which has a magnitude of 21. So how do we generate? We just multiply 21 with this a cap, because a cap has the magnitude of 1, and that multiplied by 21 will give the direction as same as this vector and magnitude 21. So 21 multiplied by this, so each component will be multiplied. Okay, this is how we multiply scalar to a vector. So 2 by 7 will be multiplied, 3 by 7 will be multiplied, 6 by 7 will also be multiplied. So you will get 7, 3 factor is there na? So 6i minus 9j plus 18k. Okay, basically 7 was in division, so I cancelled it with 21. So that gives us 3 factor of multiplication, or you multiply every term with 21, solve it. That's the answer. So every time he is asked you to get in the same direction and has some different magnitude, first of all get the direction and then multiply that vector with whatever magnitude is required. Okay. All right. Now one concept we introduced in the starting, a vector, b vector. Let's introduce now ab vector. Okay. Position I discussed na? Position vector, suppose only one point was there, so the position of OP vector will be given by x1, y1, z1. So I'll take the same diagram. All right. Let's forget about this. Let's take another vector. Okay, let's say this is a vector. The position vector is a vector. The position vector is b vector. Okay, so basically your coordinate x1, y1, z1 with ijk. You'll write like that. Okay, and you want a vector from a to b. Okay, you want to generate a vector from a to b. So how will you generate ab vector? Okay, so I'll put the heading as ab vector. Okay. It's a very simple concept, but still sometimes people forget this. So your ab vector, first of all, will be given by b vector minus a vector. Okay. Position vector of a minus position vector of position vector of b minus position vector of a. And similarly, suppose you want to go for reverse, instead of ab vector you want ba vector from b to a, so that will be given by a minus b. So whenever you want to generate any vector, you subtract in reverse order. ab vector will be b minus a vector, and your ba vector will be a minus b vector. Let's understand with this with the help of an example. Okay, so it's in 2D, but still the idea follows. Find AB vector if A is 1, let's say 1, 2, 3, and B is 1, minus 1, minus 1, 1, minus 1, 2. Okay, like this. Let's write 2, 1, minus 2. Okay. So if you want the AB vector, first of all write A vector, write B vector. How do you write A vector, B vector? Basically you put I, j, k with them. So 1i plus 2j plus 3k. It's as simple as that. B vector you want to write 2i minus 1j plus 2k. Okay, I, j, k, I, j, k. Now you write AB vector. That's B vector minus A vector. So you subtract them. So B minus A. So 2 minus 1 is 1i. Minus 1 minus 2. So that you will give minus 3j. And 2 minus 3 is minus 1. So minus 1k. Okay. These are very direct questions. These are not even not be a questions in the exam as such. But when we'll be studying the slightly higher concepts, these will be some intermediate step. I'll ask you to calculate AB vector and you may not be able to recall that. You have to do the reverse. Okay, so keep this in the mind. Okay, all right. Lastly, for the basics, okay, these are all basics. So lastly, for the basics, you have a very peculiar thing, direction ratio and direction cosine. And students just, I don't know why, but they have the tendency to get fuzzy about this topic. So as such, they are two different topics, but I'll teach them together, direction ratio and direction cosines. Okay, cosines is a bigger topic. Direction ratio involves the same idea. Okay. So let's take a vector. Let's take a vector, let's say A. So A1 I cap, A2 j cap, A3 k cap. Okay, 1 2 3 some numbers, I don't know. That's your A vector. Now if I ask you what is the direction ratio, okay, so direction ratio of A vector is A1 A2 A3. It's as simple as that. Okay, so basically direction ratio means components. Okay, it's just that the word makes it look like it's going to be very much complicated, but it's actually not. Okay, so direction ratio of A vector is A1 A2 A3. That's it. Means ijk component, they are called direction ratios. So the question, suppose the question says you have a vector or you have a line, let's say, because later you will be studying about line. You will have a line with direction ratio 3 minus 2 1, something like this. So basically you add ijk with that and you get yourself a vector. It's as simple as that. Remember, this is not coordinate because I have not put a bracket, so this is not a coordinate representation. Okay, now comes direction cosine. So direction cosine, again, students have the tendency to learn formulas for it. Yes, you can learn. I mean, it's not difficult. I will also give you the formulas, but just understand, direction ratio cosines are components, okay, of A cap vector. So you convert any vector to a unit vector and look at its component. Right now your components are A1, A2, A3. So first of all, convert this into unit vector. So A vector will be A1i, A2j, A3k divided by its magnitude. And what's the magnitude? Root A1 square, A2 square, A3 square. Okay, this one also same thing. So I'll need more space. 1 second. It will require more space. So A1i, A2j, A3k, and each component will be divided by the magnitude, that is A1 square, A2 square, A3 square. Okay, A1 square, A2 square, A3 square, A1 square, A2 square, A3 square. These components are called direction cosines. That's it. Now if you want to learn this as a formula, your call. I'm not saying anything. It's just that if you learn this, I don't think you are supposed to learn that. You just convert any vector to a unit vector and look at its component. That's direction cosine. Now there are special symbols used for it. The first component will be represented by L, the second component by M, and this is N. Okay, so I'm not writing separate formulas. L is this component, M is this component, N is this component. Okay, also then you have some properties regarding L M N. That is L square plus M square plus N square is always 1, and if you look at very carefully the expressions, you will understand why. Do the L square, do the M square, do the N square, A1 square, A2 square, A3 square. denominator squares and square root will cancel, and denominator is same, so pretty much everything cancels out, so you will get 1. So do remember this property. And finally, why this idea is slightly typical. Let me see if I can get a diagram to help you understand. No, vector section formula, mirror formula, that is done. I have a figure that could work. 1 second, I'll get it. All right. Let's see if you can understand. Although you will not be required to visualize it, but if you slightly understand this with the help of a diagram, it makes it simple. Okay. So you have this key line here, right? This is the vector, main vector. Now it's in 3D. The problem is that's why it's difficult to visualize. That's why I was not drawing that. Okay. Now this is sort of a line segment. So if this line, it will make some angle with x-axis, let's say alpha. It will make some angle with the y-axis. I'll use different colors. Some angle with y-axis, let's say beta, and this makes some angle with z-axis. Okay, gamma. All right. Now L is basically your cos alpha, M is cos beta, N is cos gamma. Okay, where alpha, beta, gamma are angles with x-axis, y-axis and z-axis. Okay, so they are basically angles. Okay. Let me put this in a box. Okay. L square, M square, N square is 1. So if you further modify, if you put this alpha, beta, gamma, cos alpha, cos beta, cos gamma, so you'll get cos square alpha plus cos square beta plus cos square gamma is 1. Okay. Don't try to learn this as a separate formula. Just remember L square, M square, N square is 1, and alpha, beta, gamma are cos alpha is L, cos beta is N, cos gamma is N. So you get this formula effectively. Okay. We used this in this. Okay. And now you get the sense why they are called direction cosine, because cos is involved. Okay. So if you want to find angle with the x-axis, y-axis, z-axis for any vector, okay, or any line, this is what is going to help you. Okay. Now let's look at one question. If a unit vector A makes pi by 3 angle with I cap and pi by 4 with j cap, and theta with k cap, find value of theta. You have to find theta. Okay. So you have a vector is making, the moment it says angle with I cap means basically x-axis. He's talking about x-axis. This one he's talking about y-axis. This one he's talking about z-axis. The moment you see this, first thing that you should come in your mind is cos alpha, cos beta, cos gamma. So basically he's indirectly or directly giving us lmn. So L is cos alpha. Okay, so this angle here, it's alpha, this one is beta, this one is gamma. Okay, so cos pi by 3, m is cos pi by 4, n is cos theta. And what is the other relation? I told you don't try to learn this cos square alpha plus cos square beta plus cos square gamma is 1. You try to do it like this, L square plus m square plus n square, that's 1. So put the values. Cos pi by 3 is cos 60, that's sin 30 1 by 2 1 by 4 plus pi by 4 1 by 2 plus n square cos square theta is 1. So cos square theta is 1 by 2 plus 1 by 4, 3 by 4, take it on the other side, 1 minus 3 by 4. So cos square theta is 1 by 4. Cos theta is, remember square is there, so plus minus 1 by 2. So you should get two values, cos theta is 1 by 2 or cos theta is minus 1 by 2 also. Okay. So in that scenario, theta is, cos theta 1 by 2 is again 60 degree or pi by 3. But in that scenario, theta is, cos is negative in the second quadrant, so pi minus pi by 3, that's 2 pi by 3. Okay. Use inverse trigo if you want to know how we solve this. Take this theta in the, take this cos on the other side. So theta is cos inverse 1 by 2 and theta is cos inverse minus 1 by 2, and you should know how to solve that. Okay. At this level you should know. We have already run inverse trigo, so in case you are unable to get this 2 pi by 3 as the answer, go refer to your chapter of inverse trigo. Right. Fine. That pretty much summarizes how to deal with this basic of this chapter. The second half of this chapter basically deals with dot and cross product, and those part particularly are very much relevant. These are only basics. Those part will make the concept of your vectors. Main concepts, I'll say. These are basics, those will be the main concepts, and those concepts will be again further used in your 3D. Okay. All right. Fine. I'll end the session here. See you in the next class. Good day, everyone.